Hello and welcome back to e-sipnayan. For today's video, we are going to discuss the hypothesis test involving t-test. The learning objectives would be first to solve word problems involving t-test, identify the degree of freedom given a sample size, then use the t-table to make conclusions for hypothesis test involving t-test. We will first recall some of the cases of tests concerning the population mean. So in hypothesis testing, we can use two different tools, particularly z-test and t-test. It's just a matter of knowing which one is more appropriate to use given some scenario or given some information regarding the problem. So for cases 1 and 2, these are the cases wherein we are going to use z-test. But you already learned this one on the previous video. That's why we are going to focus now on t-test. So for t-test description, we are pertaining to a small sample test concerning the mean of a population and unknown variance. So for us to be able to elaborate when to use t-test, let's proceed with this slide. It was mentioned a while ago that t-test is more appropriate use than z-test if the sample size is less than 30. So in this case, if our sample is less than 30, then we can consider it as a small sample. Now it's also stated here that there is no given variance or standard deviation about the population. Instead, what's given is the sample standard deviation and sample variance. Also, in t-test, the population should be normally distributed. In terms of formula, this is what we use. T equals x bar minus mu all over S over the square root of n. You know very well what x bar is. That is the sample mean. Mu is the population mean. This is the new variable that is unfamiliar yet to you, but we designate S as the sample standard deviation. And lastly, n is the sample size. Notice that when you compare this formula to the z-score formula, it is almost exactly the same, except we are solving for t, and the standard deviation is represented as S instead of sigma. Now, what's the difference between S and sigma? S pertains to the sample standard deviation, whereas sigma is for the population standard deviation. So let's discuss some other things you need to know about t-test. And one of this would be degrees of freedom or DF. For the formula, this is computed using this formula, which is n-1. So this pertains to DF or degrees of freedom. And what is that? It's a mathematical restriction put in place when estimating a statistic from an estimate of another. So here is an example. A group of 25 individuals participated in an aerobics fitness program to lower their heart rate. We're talking here about a sample size of 25, and to get the DF, we simply subtract 1 from the sample size and we get 24. Hence, the value of the degrees of freedom is 24. Now, why is it important to know what is the DF? It's because using the t-table later on, we need this information regarding the DF for us to be able to identify the critical value. Now, that will be elaborated a little later. For now, let me recall the steps in performing hypothesis testing involving t-test. Now, these are the information essential per step that I want you to take note of. So, for the first step, you need to formulate the null and alternative hypothesis. So, for the alternative hypothesis, you need to further specify if you use one-tailed or two-tailed. If it is one-tailed, the symbol that you used in the alternative hypothesis was not equal. Meanwhile, for one-tailed, it can either be greater than or less than. If it is greater than, this is the so-called right-tailed, whereas if you use less than, then this is the so-called left-tailed. And these are the information needed for step 1. For step 2, you need alpha. This alpha will be used to identify the critical value along with the degrees of freedom. So for the degrees of freedom, you need, of course, the sample size because the formula is n-1. And lastly, you need to identify the critical value using this information, and this can be found on the t-table. For step 3, you need to simply solve for the t-score using the formula. And for step 4, you make the decision by rejecting or accepting HO based on the position of the test statistic in our illustration for our normal curve. Let's now practice how to perform hypothesis test using t-test. Before that, let me present to you some guidelines on how to use the t-table. So as of now, hopefully we're able to get a copy of the t-table so that you know what I am talking about for this portion. Now, in the t-table, there are two headings there. One pertaining to two-tailed types of test. One is for the one-tailed types of test. So the t-table will be consisting of different values but will all be positive. So basically, how will we know if it is negative or positive? Initially in the table, they will be at default positive. But when you were able to identify that we will be using two-tailed test, you get both the positive and negative of the obtained critical value. If it is one-tailed and right-tailed more specifically, the critical value will stay as is, positive. Lastly, if it is left-tailed, then you get the negative value of the critical value since we are pertaining to the left side of the normal distribution. Now, for us to be able to apply this, let's now proceed with word problems. A recent survey stated that Filipinos send an average of 1,500 text messages per month. To verify this claim, a researcher surveyed 16 Filipinos at random and found out that the average number of text messages they send per month is 1,486 with a standard deviation of 54. At alpha equals 0.05, is there enough evidence to support the survey's claim? Let us first try to check why is this word problem pertaining to t-test. So remember, we are using t-test first if our sample size is less than 30. Here in this particular word problem, our value of n or the sample size is 16, which is indeed less than 30. So the first consideration is satisfied. How about the next one? We are not given with the population variance or standard deviation. What's given instead can either be the sample variance or the sample standard deviation. Again, going back to this problem, we can see that there is a given standard deviation, but the standard deviation, which is 54, pertains to the sample standard deviation because this 54 here describes the data obtained from 16 Filipinos. So we are given with the sample standard deviation. Hence, we can verify that this one is using t-test. Let's now proceed to hypothesis testing. In step 1, conduct the null and alternative hypothesis. So for the null hypothesis, we need to identify what is the assumption about the mean, and it can be found here on the first sentence. So here it says that a recent survey stated that Filipinos send an average of 1,500 text messages per month. So we are talking here about the average number of text messages sent per month, and the population would be all Filipinos. It is assumed to be 1,500. So this 1,500 here is our mu. So how do we state now our null hypothesis? We can state it in symbols or we can also state it in words. So in symbols, the null hypothesis is mu equals 1,500, or the average number of text messages sent per month for all Filipinos is 1,500. Moving on, let's identify what is the alternative hypothesis. The alternative hypothesis can be identified by determining what is the goal of this particular research. And it says here that we need to answer this question. Is there enough evidence to support the survey's claim? So basically, this is a question generally asking us whether or not the null hypothesis is true. So it's not something specified, but rather generalized. Hence, it will be a two-tailed alternative test. So mu here is not equal to 1,500. So again, why is it not equal? It's because our goal in this particular problem is to simply verify whether the assumption is correct or not. There's nothing stated that we need to prove greater than or less than the assumed mean. Hence, we use not equal. And so, this is a two-tailed type of alternative test. And we are done with step 1. For step 2, we need the following information: alpha, n, df, and cv using the t-table. Let's first identify what is alpha. It's very obvious. It's given in the problem. Alpha is 0.05. How about n? N is the sample size, which is 16. We need n for us to solve for the df with the formula n minus 1. So the df would be 16 minus 1, which is 15. Then lastly, we are going to use this information to obtain the critical values. Now I will be going to the part where we are going to use the t-table. So this is our t-table, and at this point, you will learn how to use the t-table. So basically, what are the information that we need for us to be able to use the t-table? So based on the given a while ago, we know that the type of alternative hypothesis that we were able to construct is two-tailed or non-directional. We also were able to identify the value of alpha, which is 0.05. And lastly, we also know what is the degrees of freedom, which is 16 minus 1, which is 15. Now, these are the essential information that we need for us to be able to know the critical value. So let's first identify or refer to the row having two-tailed alpha. So this is this part. Two tails means we are pertaining to two-tailed types of alternative hypothesis. Then we know that alpha given is 0.05. So we are going to consider this row and find where is 0.05, and it is here. Then lastly, for us to be able to identify the critical value, we need the df, and df is the first column of this table. We were able to determine a value of 15, which is here. Therefore, if we look at their intersection, let me just highlight that. If we look at the intersection of df of 15 and two-tailed alpha equals 0.05, then our intersection is 2.131, and this is our basis for the critical value. So going back, if we are looking for the critical value of two-tailed, remember that I mentioned last time that we should get both the positive and negative sign of the critical value. It's because we are pertaining to both ends or both tails of the normal curve. Hence, the critical value is 2.131. Moving on to step 3, we're simply going to solve for the test statistic or the t-score using this formula. So we need to identify this information so that we can solve this accurately. So sample mean here is given as 1,486. This is the mean describing the sample size, which is 16. For the mu, it is stated in step 1, and our value for the mean or mu is 1,500. Sample standard deviation is also given as 54. And lastly, our n here is the sample size, which is 16. After that, we are just simply going to plug in the values, then simplify. Therefore, the test statistic is t approximately equal to negative 1.04. Lastly, for step 4, we are now going to do the conclusion or the decision in such a way that we are going to analyze our illustration or graph regarding the normal curve. So say for example, this is our normal curve. What we're going to plot here would be the critical values and t. Let's first graph the critical values. Remember that the critical values will be our basis for the rejection region. So what we need to plot here would be negative 2.131 and positive 2.131. If we plot negative 2.131, it will be in between negative 3 and negative 1. And this will be our starting point. And everything to the left would be the rejection region of the left tail. Meanwhile, if we plot positive 2.131, this will be our starting point for the rejection region for the right tail. Therefore, the area shaded in red will lead us to the conclusion of rejecting the null hypothesis. Meanwhile, the unshaded region will be for accepting the null hypothesis. So what is our test statistic? We were able to solve a while ago the value of t, which is negative 1.04. This is now what we're going to plot next. So negative 1.04 is plotted here. Therefore, it falls within the acceptance region. So let me just highlight this portion. This is the unshaded red region. Let me shade it in blue. And if the test statistic falls within this region, then our decision is to accept the null hypothesis. So simply observe which region does the test statistic fall. Obviously, it falls within the acceptance region, which is the blue shaded part of the normal curve. Therefore, what will be our decision? Our decision is to accept the null hypothesis. Hence, we are going to reject the alternative hypothesis. And that is how you conduct the 4-step hypothesis testing using t-test. Let's now proceed to another example. A researcher wants to determine if review sessions affect performance of students in exam. A review session is administered to a sample of 25 students, and after the examination, a sample mean of 43 is calculated with a standard deviation of 8. From the previous exams, it was identified that the population mean for the same exam is 40. Can the professor conclude that the review session is effective in improving exam performance? Use alpha as 0.10. So we start by constructing the null and alternative hypothesis. So we need to identify in the problem which part is talking about the assumed value of the population mean. So basically, this is that part. It was identified that the population mean, it's explicitly mentioned here that the population mean is equal to 40. Therefore, our mu would be the value of 40. It's obvious because it's stated here that that is the population mean. So for the null hypothesis, mu is equal to 40. For the alternative hypothesis, we need to take note what is being asked in this particular problem. And in this case, we are asked if the review session is effective in improving exam performance. So basically, we are after testing if the exam will lead to an improved score. And when we talk about the word improve, basically this is related to a symbol which is greater than, because improve means something greater. Hence, for the alternative hypothesis, mu should be greater than 40. That is what we want to prove. Also, we need to specify that the alternative hypothesis type is right-tailed so that we know the sign of the critical value later on for the critical values. For step 2, identify alpha, N, DF, and CP. So alpha here is 0.10, obviously. It's given. N is 25 because a sample of 25 students were selected. And then for the DF, that's again 25 minus 1 equals 24. Then afterwards, we use the t-table to find the value of CP. So again, it's right-tailed and alpha is 0.10, DF is 24. So let's go back to the t-table. Again, this time it is one-tailed. Our alpha is 0.10 and DF is 25 minus 1, which is 24. So we are now going to consider one-tailed, and then our alpha is 0.10, it's here. Then DF is 24. Then after that, simply identify the intersection, and we will be able to identify the critical value. And the critical value here is 1.318. It will stay positive because we are talking about a right-tailed alternative hypothesis. Moving on for step 3, we compute the test statistic. So again, we identify what is the sample mean. The sample mean given here is stated a sample mean of 43. So this is the sample mean. Population mean is the one stated in the null hypothesis, that is 40. Sample standard deviation is also identified, standard deviation of 8. And then lastly, our N here is 25 students. So plug and chug, the value of T will be equal to 1.875. And this will be our test statistic. For step 4 or the decision, again, we are going to graph it on the normal curve so that you can illustrate. Now, again, we are going to plot the critical value obtained from the t-table. So this time, it's positive 1.318. If we plot it here, it will be somewhere in between 1 and 2. And since it is right-tailed, we are going to shade the portion to the right. And this will be our rejection region, or will lead us to the conclusion that we are going to reject HO. Meanwhile, for the unshaded region, or it's better if I shade it as another color for emphasis, this will be our acceptance region, or it will lead us to the conclusion to accept HO. Now, the next thing that we need to plot is the test statistic, which is 1.857. So, obviously, 1.875 rather is in between 1 and 2. But it's a little greater than 1.318, so it must be found to the right of 1.318, which is the critical value. And it will fall somewhere here. So this is our test statistic, and notice that it will fall within the rejection region. Hence, the decision is to reject HO, and we are now going to accept the alternative hypothesis, where mu is greater than 40. So basically, to answer this question, can the professor conclude that the review session is effective in improving exam performance? The answer is yes, because the accepted hypothesis is the alternative hypothesis, which says that the mu is greater than 40. Lastly, for example number 3, the accounting department of XYZ University claims that the mean monthly salary of their teachers is 21,750 with a standard deviation of 6,000. A researcher takes random sample of 25 teachers and found out that they have a mean monthly salary of 19,375 pesos. Do the teachers have lower salaries than the rest? Test the claim at 0.01 level of significance. So let's start by formulating, again, the null and alternative hypothesis. So the null hypothesis is the assumed value of the parameter, which is in this case can be found on the first sentence. So the claim or the assumption is that the mean monthly salary of teachers is 21,750. So that 21,750 stated there is our mu, or the population mean, because this is the assumed value. So the null hypothesis can be represented as mu equals 21,750. How about the alternative hypothesis? Let's try to identify the goal of this research. And it can be found on the question. So basically, we need to know if the teachers have lower salaries than the rest. So basically, we want to prove something, and we want to prove that the salaries must be lower than the assumed average. So for the alternative hypothesis, that will be mu less than 21,750. And we specify this again as one-tailed, or more specifically, left-tailed, because we use less than. Step 2, identify alpha, N, BF, and CB. Alpha is 0.01, it is given. Our value of N is 25 because there is a total of 25 random samples taken. And then, aside from that, we need the DF. So that is again the formula N minus 1, or 25 minus 1. DF is 24. Then we go back to the T table to identify the critical value. So remember, it's left-tailed, alpha is 0.01, and DF is 24. So this time, it is left-tailed, or one-tailed. Alpha is 0.01. DF is 24. So we are going to use this information to identify the critical values. Let me just change the color so that we won't be confused with the other annotations. Okay, so since it's taking some time, ayan, let's use red this time. We are again having a one-tailed type of hypothesis test. Alpha is 0.01, is here, so let's locate, it must be here. And then our DF is 24, so this will still be our basis. Then we simply need to identify the intersection, just like what we did on the two previous examples. So the critical value that we were able to find out is 2.492. 2.492. Okay, so here it's stated that it is negative, and it is negative because it is left-tailed, or we are talking about a less than symbol used in alternative hypothesis. So for step 3, plug and chug and solve for t, we'll get negative 1.98. That is our test statistic. And lastly, for the decision, for us to make a conclusion, we graph our critical value, that's negative 2.492. So we are going to plot it here. It's in between negative 3 and negative 2. Then shade all the areas or region to the left because this is left tail. So if our test statistic fall within this region, then we reject HO. Then for coloring purposes, we are going to shade the remaining region of the curve, and this will lead us to the conclusion to accept the null hypothesis. How are we now going to make the conclusion? Let's plot t equals negative 1.98. Negative 1.98 obviously will fall somewhere in between negative 2 and negative 1. And this is the test statistic. It's very obvious which region did it fall, and it is on the acceptance region. Therefore, for the conclusion, we are going to accept the null hypothesis, and we are going to reject the alternative hypothesis. Therefore, to answer the question, do the teachers have lower salaries than the rest? The answer is no. It's because this is the hypothesis that we were able to choose after conducting the 4-step hypothesis. So the salary in average is still 21,750. There's no enough evidence that the 25 teachers have lower salaries. So the answer is no. And that is how you do hypothesis testing. That will be all for this video. See you again on the next one. Goodbye.